Welcome to GateX AML. We'll solve a few problems on the concept of quadratic forms. Consider the quadratic form given which of the following is true. So to find this, to find the eigenvalues. Based on the eigenvalues, you can tell whether it's definite or indefinite. So let us write the matrix for this first. So how many variables? 2 are there. So we'll have a 2 cross 2 square matrix. So just in the first problem, I'll tell you how to write. Okay, already you know it. So this is A11, A12, A21, A22. In the quadratic form, this is symmetric, that is A21 will be equal to A12. So convert this to this matrix form. So this I can write it as 4x1 into x1 plus 2x1 x2 plus 2x2 x1 plus x2 into x2. Okay. This is A11, A12, A21 and A22. And if you observe, A21 and A22 are A21 and A12 are symmetric. So your matrix A is equal to this 4, 2, 2 and 1. Now find the eigenvalues for this. So that is A minus lambda I, determinant of this equal to 0. So 4 minus lambda 2 into 1 minus lambda equal to 0. So this is 4 minus lambda into 1 minus lambda minus 4 is equal to 0. This 4 minus 4 lambda minus lambda plus lambda square minus 4 is equal to 0. Get cancelled. This lambda square minus 5 lambda is equal to 0. So lambda into lambda minus 5 is equal to 0. So we have eigenvalues as lambda equal to 0 and another eigenvalue is 5. So that means what? My lambda values are greater than or equal to 0. That means what? It cannot be positive definite. Positive definite means lambda greater than 0. Greater than 0 is positive definite, all the values lambda I. Negative means negative definite means all less than 0. Indefinite means both negative and positive. Positive semi-definite means greater than or equal to 0. So this is the case. The answer is semi-definite. Okay. Next. Select that are true for this quadratic form. So convert this again into the matrix. Here it's a 3 variables. So I need a 3 cross 3 matrix. 3 cross 3 matrix. So how will I write? A11, A12, A13, A21, A22, A23, A31, A32, A33. So convert this into that form. That is x1 into x1 plus 2x1 or x1 x2, because I need to make it symmetric. X2 x1, so both become symmetric, plus x2 into x2 plus x3 into x3. Only these coefficients are available, rest will be 0 in your matrix. So this is A is equal to, what is 1 coefficient? 1. Is there 1 2? Yes, 1. And then 2 1 is, so this is 1 2, 2 1 is here, so this is also 1. Next 2 2, so this is 2 2, 2 2 is 1. Then you have 3 3 1. So rest are all zeros coefficient. Okay. So now find the eigenvalues and rank for this. And check Q is diagonalizable. See, this option is always true. Q is diagonalizable because this matrix A is a symmetric matrix. So A is a symmetric matrix means any symmetric matrix, that is the rule, any symmetric matrix can be diagonalizable. Okay. So since Q is a symmetric matrix, let us write it as Q, then it is diagonalizable. This is true. Then you check others. Let us find the rank of this. So convert it into row echelon form. So you observe this, these two rows are same. So they become 0. Let me write that 0, 0, 1. I am bringing this last row first. Then 1, 1, 0. Then I am subtracting these two rows. It becomes 0, 0, 0. Then again swap these rows. So it becomes 1, 1, 0, 0, 0, 1, 0, 0, 0. That means what? This is in row echelon form. So now, how many independent rows are there? 2 independent. So rank is 2. Is it Q is positive definite? So you find the lambda value. So it's a upper diagonal matrix. So lambda will be diagonal elements, that is 0, 1. So lambda is greater than or equal to 0. Okay. So that is positive semi-definite, not positive definite. So 2 and 4 are the answers. Next, find the rank of the quadratic form. So again, 3 variables. So 3 cross 3 matrix. So from now I will just write directly the matrix. Let us say this is Q equal to, so 1, 1 is there. Then 2, 2 is there. 2, 2 is 1. Then 3, 3 is also 1. Minus 2 x1, x1, x2. So 1, 2 is minus 1. And then 2, 1 will also be minus 1. Then x1, 3 is there. 1, 3 is minus 1. 3, 1 will also be minus 1. Rest will be 0. And this will be symmetric matrix here. Minus 1, minus 1, minus 1, minus 1, 0, 0. Symmetric. Find the rank of this. So convert it into row echelon form. To convert 1 minus 1, 1. So this is a pivot element. So add this to the last row to make that 0. So this becomes 0. This becomes minus 1. Becomes 0. Can I further reduce this? Try to make this 0. So this will be 1 minus 1 minus 1. This becomes 0. This also becomes 0. This is minus 1, 0, minus 1, 0. Can I further reduce it? I cannot further reduce it. So this is the highest form. So there are 3 rows which are independent. So rank is next. Given this, find whether it's definite or indefinite. Okay. So again, only 2 variables are here. So 2 cross 2 matrix. 1, 1 is 3. Okay. And 1, 2 is minus 1. 2, 1 is minus 1. And this is 1. 3 minus lambda. Find the eigenvalues. Minus 1. 1 minus lambda is equal to 0. So 3 minus lambda into 1 minus lambda minus 1 equal to 0. This is 3 minus 3 lambda minus lambda plus lambda square minus 1 equal to 0. This is lambda square minus 4 lambda plus 2 is equal to 0. So if you solve this using quadratic equation, you will get plus or minus 2 plus or minus root 2. If you observe the lambda value, both are greater than 0, not equal, greater than or equal to 0, no 0 here. So no negative value also. 2 plus root 2 is greater than 0. 2 minus root 2 is also greater than 0. So that means what? It is positive definite. Next. So same thing again, 3 variables they are given. Find out which of them statements are true. So you have to find rank, eigenvalues and positive definite if it is check. So based on the eigenvalues you get. So write down the Q matrix. So quadratic form matrix, I can write it as 1 1 is there, so it's a 3 cross 3 matrix. So 2 2 is there, 3 3 is there, 1 2 is 1, 2 1 will be 1, this is 1 3, and 3 1 is minus 1, rest are 0. So it's a symmetric matrix. Now try to convert it into row echelon form. So if I try to convert it to row echelon form, so try to make this third row 0, 1 1 minus 1, 1 1 0, this becomes 0 1 0. Now can I further reduce it? Try to make this 0. So that is 1 1 minus 1, this becomes 0 0, and then 1 0 1 0. So can I further reduce it? No. So there are 3 independent rows, so their rank is 3. Then what is the eigenvalue for this? So you check 1 minus lambda into 1 minus 1 0 0 minus lambda 1 0 1 minus lambda. So if you check this, you'll get, you know how to get the eigenvalues. So I'll just write the eigenvalues for this. You just verify your answers. 1 comma 1 minus root 2 and 1 plus root 2. So if you observe here, this is negative, this is positive. Okay. So what it means? Only this statement is true. So it is not positive definite, and all the eigenvalues are not positive. So only this 3 is correct. Next, find the canonical form of this. So canonical form, how will you find? Q of x will be equal to summation of I equal to 1 to n lambda I into yi square. Okay. So if it is a real symmetric matrix, if you get a symmetric matrix, then this I can apply canonical form because it can be orthogonally diagonalizable. Okay, symmetric matrices are orthogonally diagonalizable. So what is that? I need not find any orthogonal matrix here. So just find the Q matrix here. So if it is symmetric, then it becomes automatically diagonalizable. So this is 1 1 is 5, then is 1 1, then 2. Okay, find the lambda values for this. 5 minus lambda 1 1, 2 minus lambda equal to 0. So that implies 5 minus lambda into 2 minus lambda minus 1 equal to 0. This 10 minus 5 lambda minus 2 lambda plus lambda square minus 1 equal to 0. So if I guess all this, lambda square minus 7 lambda plus 9 equal to 0. So solve it using solution for quadratic equation. You will get lambda 1 value as 7 minus root 13 by 2, and another lambda 2 is equal to 7 plus root 13 by 2. So what is my form here? So lambda 1 is 7 minus 13 by 2 into y1 square plus 7 plus root 13 by 2 into y2 square. This is the canonical form. Next, find the rank and signature of the quadratic form. So rank, you know, I will explain what is signature means. So let us write this 3 cross 3 matrix. 1 2 2 is 1, this is minus 1, x1 x2 is 1, then the rest are zeros. Okay, so this is a symmetric matrix. What is the rank of this? Convert it into row echelon form. So this is, these two rows are same, so I can make it 0. I can write directly as Okay, can it be further reduced? No. So you can just write the final like this, the pivot elements like this. So there are two independent rows. The rank of this matrix is 2. What is signature? For a signature, you have to find out how many eigenvalues are positive or negative. The signature means number of eigenvalues positive, comma, number of eigenvalues negative, and number of zero eigenvalues. So for this, I will get the eigenvalues as lambda 1 equal to 1, lambda 2 equal to 2, sorry, minus 1, 2, and lambda 3 equal to 0. Okay, you can just verify. So here, how many values are positive? So signature I will write here as there is one value positive. This positive is one value. How many values are negative? One value is negative. So 0 value is 0. Sometimes you can also write it as plus, minus, and 0. This indicates what? The existence of positive eigenvalues, negative eigenvalues, and 0. Okay, this is how you write the signature. Thank you for watching. We will continue with the last concept in this subject, that is singular value decomposition, in the next video. Please like, subscribe, and share.